All right. So I got this email from Selena a few months ago saying, so I've got this conference, and I wonder if you could talk about why Django chose to recommend PostgreSQL. And this was an interesting request, because technically we don't actually recommend PostgreSQL. So this is the thing, right? As a project, we have this opinion in our community that we're really good at web. We're really good at web frameworks, right? At this sort of middle layer of your application. We kind of don't do much in the front end because we're not front-end developers, and we don't want to tell our users what they should be doing on the front end. And we aren't DBAs or, systems administrators, so we don't really want to make calls about what our users have to do on the back end. So as a project, we kind of try to have this somewhat agnostic, somewhat neutral stance on which tools we recommend on sort of the outsides of the rest of the stack. So Django worked with Postgres, but it also worked with MySQL, Oracle, DB2, SQL Server, and a bunch of other databases that I barely know exist, right? I did a Google search to see, what database drivers, and found like a half dozen database drivers for Django for databases I hadn't heard of until last week. So theoretically, we are database agnostic. But of course, we have to make a choice. I'm not database agnostic when I sit down to write a website. I can't, I have to choose something. And as a matter of fact, it's sort of a dirty little secret that Django really loves Postgres. So in that sense, Selena's right. Postgres is kind of the default, right? The vast majority of the core developers use Postgres. I almost wrote all, but I think there might be like one or two who don't. And certainly the people who help maintain the Oracle backend, I presume they use Oracle from time to time. But even like if you go through the Django tutorial, right there in the first tutorial, there's some explanation of how Django generates SQL, and it says right there in the tutorial, the authors of this tutorial use Postgres, so the examples will be Postgres specific, right? And there's like an acknowledgement kind of slipped in there, right? It's kind of the first few paragraphs you read when you're learning Django that, as a matter of fact, we're not quite as agnostic as we say. When people ask for advice on implementing their own database backend, we point to the Postgres backend as sort of the reference implementation. We often joke when we're core developers meeting together that if we could become a Postgres-only framework, our jobs would become so much easier. So why do we choose Postgres? Why is it such a default? Why is it such a win among the Django developers? I think the reason is, so you can see it in the fact that we recommend the Postgres backend as sort of our de facto default reference implementation. We don't have to like hack around anything. Everything just sort of works. Sort of an anticlimactic answer, right? There's no big reason. It's just that everything works as you expect it to. But you know this. This is why you're here, right? You know this about Postgres. I don't have to tell you anything particularly special about it. I'm using Postgres for the same reason you all use Postgres. And the reason that the Django core team is predominantly, is dominated by Postgres developers is because we are pragmatists trying to get a job done, and Postgres fits right in with that requirement. We want to get something that's right. We want to get something that works. We want something we don't have to do weird workarounds and hacks. The fact is, Postgres has been my default for over 10 years, and it's just never given me a reason to doubt it. So that's my keynote. Thank you very much. No. I tried to build a whole keynote around answering that question, but it's an easy answer, right? But what happened was this idea of the default choice, started kind of kicking around and floating around in my head. And so that's what's led to the rest of this talk. So I'm super excited about this opportunity. Thank you so much for inviting me. What's really cool about getting to speak here is that, as Selena said, I do a ton of speaking, but most of the time I'm the insider. I'm at DjangoCon wearing kind of my core developer hat. I'm at PyCon speaking as a Python developer with like 15 years now of Python experience. I'm at a web conference, and I have credibility as a maintainer of a popular web framework. I'm an insider. I know the people, I know the community, I know the factions, I know the details of the internals. Often I know a lot more than I want to know. So here it's actually very different. I'm a fanatical Postgres user, but ultimately I'm just a fan. I don't hang out on the developer mailing lists. I don't know most of the core team. I know a few of you all by name, but I know very few people by sight. This is really cool, getting to be an outsider. In fact, this is actually my first Postgres conference. So this is really cool. And I'm incredibly excited to get to be in that role. And the thing that's so exciting about that is that we have this tradition at DjangoCon of people giving the Why I Hate Django talk. This started at the very first DjangoCon we held in 2008, where Cal Henderson of Flickr, not a Python user, not a Django user, but an incredibly opinionated web developer, gave a hilarious talk explaining why he hates Django. Among other things, he blamed the core team for not having serious beards, because web developers come from serious people with serious beards. So I'm doing my best. I don't know. You tell me, is it serious enough? We'll see what I can do. So the thing is, this has been like my hobby horse. Every time someone works on DjangoCon, I say, hey, who's giving the Why I Hate talk? And the thing is, as an insider, it's very easy to go to these conferences and just hear the same stuff over and over again, be inside that same echo chamber and just hear the same things. And frankly, praise doesn't do much for me. I like to know, I like to see what I'm doing through other people's eyes. I like to remember what it's like to come into something fresh, come into something new. And when I hear these kinds of talks, I come away inspired. I come away rededicated to this work, because I get to see what I'm doing from a fresh perspective, from a fresh new direction. And in fact, most of these talks have led directly to some of the best improvements that have happened in Django. They remind us of those sort of problems that we've internalized and forgotten about, and galvanize us to fix them. I've been wanting for a while to go through Cal's original talk and go point by point, saying fixed, 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 because we really, for a few years after that, used it kind of as a talking point. So now, this isn't exactly one of these talks. I don't have much to say because I don't hate Postgres, even in jest. Frankly, there's going to be more here under a praise heading, but this is an outside perspective. This is my perspective as a web developer. Out of curiosity, how many people here do web development? Okay, so it's like roughly like a third. That's about what I expected. Normally, my crowd, everyone would have raised their hand. I'm kind of generally talking to web people. So this is the perspective as someone who writes web software for a living, someone who helps other people write web software for a living. And hopefully it'll give you some ideas of what we want, what we're looking for in databases. And I think I have some ideas about how Postgres can Postgres is kind of poised to kick some serious butt in this world. And it's so close. And I just want to give you the little kick to get you over that edge. So let's get to it. So LAMP, you're familiar with LAMP? Yes? When you describe shorthand what stack you use as an open source developer, you often say, yeah, I'm a LAMP developer, right? Of course, like a lot of these buzzwords, it's not really that accurate. LAMP originally stood for Linux, Apache, okay, fine. MySQL, Perl, no, that's kind of a lie, right? Almost nobody actually uses this precise stack anymore, right? Apache has a lot of alternatives now. MySQL has a lot of alternatives. Perl, does anyone really do new greenfields web development in Perl? Few people do. There's actually, anyway, that's a tangent. I'm not going to. I have a sort of fetish for web frameworks, so there's a new one in Perl maybe that I was fooling around with. Anyway, so in fact, my stack is more like this, you know, Linux, Apache, Postgres, Python, even though we keep calling it LAMP. But actually, even this is a lie, right? And anyone who does web development kind of knows where I'm going here. There's actually, these days, you need a ton more in order to do a real website. This is like a very cursory architecture of what's actually involved, the moving pieces that actually run a modern website. I looked at the sort of current large-ish website that I'm working on right now, and there's these four things are here, but there's a lot more also. I also need a queue, so I'm using RabbitMQ for doing background tasks and doing queuing. And there's also some heavy search components. We chose a tool called Elasticsearch. There's also stuff like Solr and Zapier and a ton of other search engines there. We're also using Redis for some caching and some intermittent, semi-persistent data. Redis is a key value store. And we're also using MongoDB for some logging purposes. So we actually end up with, like, you know, this weird stack with an incredibly non-convenient acronym. And so rather than try to come up, by the way, as a fun Easter egg, if you Google for anagram, I was trying to find an anagram finder. Anyway, you can try it. So I've been describing this as just like a modern web stack. It's really boring. If you have a better suggestion, let me know. But if you look at modern websites, modern high-scale websites that are being developed right now, you find a lot more moving pieces than LAMP. Even if you are using a traditional LAMP stack, I'll bet you have 3, 4, 5 other moving pieces as well. So I've become pretty good at orchestrating all of this stuff, keeping it all running and connected, and making sure that any one of these pieces doesn't become a single point of failure. That's kind of been my job for the last few years. But the fact is, it's pretty complicated, right? There's a lot of pieces here. There's a lot to keep running, a lot to orchestrate. You need other pieces of software just to keep all these pieces of software all running together. And of course, in between each of these layers are little shims to do the various connections. And I haven't even talked about monitoring or you know, high availability yet, right? So there's just a ton going on here. So in the Python world, we have this thing, the Zen of Python, right? Drop into the Python shell, type import this, and you'll see kind of a succinct summary of what it means to be a Python developer. And one of the tenets of the Zen of Python is that if the implementation is hard to explain, it's probably a bad idea. So if we look at this modern web architecture through this lens, we can kind of see that it's probably a bad idea. And if you, like I do, make a point of reading downtime postmortems, this is kind of another one of my weird hobbies, is when sites go down, I can't wait until they come back up and post a postmortem so I can see what went wrong. It's nearly always some weird interaction between two pieces of software. GitHub was down last week, and it basically went down because they had a database migration event that led to increased load, which triggered some automatic failover tools. So you have like 3 different events all kind of coming together to knock the site offline. And yeah, there's, you know, there are some easy, obvious fixes there. But really, the problem is just complication. It's just the complexity of all of these pieces working together. So I think one of the biggest problems facing web development right now is that the scale of what we're building, the number of users that we have, and the traffic that we have to deal with is increasing exponentially, but our tools are not keeping up. And the number of things we have to run and orchestrate to keep this all running is getting increasingly complex and increasingly complicated. So again, you all are Postgres users, so you probably know where I'm going here, but let's just go through this exercise just for fun, right? So this is what I'm running on this particular website, right? I've got Postgres, Rabbit, Elasticsearch, Mongo, etc. But so why am I only using Postgres for my relational database, right? You know, Postgres has some queuing support, right? Listen, notify. So I could actually use Postgres for my task queue, couldn't I? Right? And Postgres has a perfectly good search engine in the form of tsearch2, so why am I not using tsearch2 as my search engine? Postgres has a key value store, right? HStore, super fast, super nice, even indexed. Redis doesn't have indexes. Kind of cool. And document database, why am I using MongoDB? It's just basically a ton of JSON data, right? Postgres has a native JSON type, and in the latest release we've now got PLV8, so I can get that sort of JavaScript-y MapReduce awesomeness that I find really cool. So why am I not using Postgres for that? Well, I mean, the reason that I'm not is because this is still kind of in my dreams. All these things exist in one database, but they're not perfect. I was talking with someone last night about the idea of trying to write a task queue based around listen notify, and I was being told that there are some sort of performance and scalability issues that I'll want to be careful with looking at that. And this document database in the form of JSON and PLV8 it's not exactly the same as MongoDB, right? It doesn't have many of the same features. It doesn't have stuff like the sort of atomic append support that I'm using for logging and that sort of stuff. But it's close, right? And I could get really, really close, but it's not quite there. So really, what I'm doing is I'm dreaming here, right? I'm dreaming of one database that can do everything that I want to do, all in one box, all in one package. Came out of the projector's a little dark, but that is the elephant. Floating there is the Eye of Sauron. This was my tweaking my slides at midnight after hanging out at the bar slide, so I hope you appreciate it. No, but really, I'm serious here, right? I think that this fragmentation in backends, in data storage, the history of software is always this history of fragmentation and then consolidation. And we're in a fragmentary stage right now. And I think the next logical stage is consolidation. I don't think our current stack is tenable. I don't think these dozens of pieces of software, each with a specific purpose and not a lot of interoperability, is the way to go. And man, I think Postgres is so close to being the database of my dreams. So what I'm going to do is I'm going to try a little experiment here. So like us web developers, we love buzzwords. Ajax, the cloud. When I explained to my mom that the cloud really just means a data center in Virginia, she was really disappointed. But buzzwords actually are kind of important. They give us a way to talk about something that we hadn't talked about before. I mean, Ajax is a great example. It's a terrible acronym. It stands for asynchronous JavaScript and XML. And almost nobody uses XML with Ajax. It's all JSON, right? And the asynchronous part is kind of not the interesting part. Anyway, it's a dumb acronym, but it gives us a way to talk about an architecture, talk about a group of ideas. So I'm going to try to invent a buzzword here. And I hope that you'll agree with me this is a useful one, and as you'll see, there's a lot of synergy with the Postgres community. So this dream database that I'm thinking of, this type of database that kind of solves all of your back-end needs, I'm calling it a post-SQL database. Now, there's some obvious resonance with Postgres here, but there's more to this than just dropping the GRE. Okay, so this is the detour into a little bit of literary theory. I have a degree in literature. Apologies for where this is going. But this post prefix is a really interesting one. And choosing to call this thing post-SQL is a conscious choice based on sort of what I know about the way that this word is, this prefix is used in literature, and specifically when we talk about postmodernism. You've probably heard of postmodern literature, at least in passing. James Joyce, David Foster Wallace, Don DeLillo, Borges. I mean, there's some really fantastic literature that falls under this rubric. It's what I spent, my time in college studying. But what's really interesting about postmodernism is there isn't really a concrete definition of what postmodernism means. If you call up the Wikipedia page, there's like paragraphs and paragraphs discussing what postmodernism kind of sort of could mean, but not. There's not actually a lot of agreement on what the term even means, which is hilarious for a genre that's been around since the 60s. So, and the reason for this is it's not a very good term. It doesn't really encapsulate anything about the form itself. So one way that people can describe postmodernism is strictly temporal, right? It's the thing that comes after modernism, right? And that's how post was originally used in PostgreSQL, right? It came after ingress, so it's postgres. So it's simply a temporal use of the word post. But I kind of find this term to be sort of intellectually bankrupt. I mean this definition, because it explains when postmodernism happens after modernism, but it doesn't really tell you anything about the form or anything interesting about what the form does. So another definition actually is one that sets itself up against and on top of modernism. What happens with modernist literature is the sort of classicalism starts to fragment. We start moving away from realism in literature and towards this sort of literary experimentalism, towards vignettes, towards loosely interconnected pieces, towards the sorts of weird experimental fiction that starts to happen with modernism. And what postmodernism says is once you open this Pandora's box, once you see the opportunities to move beyond classicism, move beyond realism, and into this new world that's far beyond, write what you know, you kind of can't go back. Once, as an author, once you've seen modernism, you can't uncork that bottle. You can't put it back in. So post in this sense has to do with sort of encompassing and absorbing what came before. It's a recognition that this thing has fundamentally changed how we view our field. And even if we think it's changed it for the worst, and even if we react violently against it and try to go back to the old form, we're still in reaction and setting ourselves against and on top of this previous thing. So hold this thought of post as against and on top of, because I have to go back now, if we're going to talk about PostSQL as being post, as in encompassing and absorbing the lessons of databases, I need to talk about what a post database would be, and I need to talk about databases themselves. So briefly, let's talk about, from a web development standpoint, what relational databases get right. Again, from a web development standpoint. This list could go on, but I've sort of picked a few things that I think are really important from my standpoint. So ad hoc queries, this is huge, right? And having this first on the list probably gives you a hint that I'm going to be talking about NoSQL next, right? But this is actually one of the biggest problems with NoSQL that you don't have with relational databases, is that you don't need to design your data for your queries. You can kind of decide after the fact what you need to do to pull your data out. The idea that this is even hard to describe as an innovation because it's so ingrained in our experiences as people working with relational databases, but the idea that you can grab a bunch of data, throw it at your database, and not really know what you're going to do with it until later is actually an incredibly salient feature. If you look at the history of successful websites, successful web companies, most of them come out of something else. I think the cool kids in California call that a pivot. But look at like Flickr, right? Most successful photo sharing site in history, started as an online role-playing game, right? So they had a photo sharing component. Turned out no one was playing the game, but everyone was sharing photos, right? They had no idea what they were going to do with that data, but they were collecting it in a way that let them pivot into a new direction. This is incredibly important. If you have to redesign your data model when you need to change directions, you've not just locked yourself into a particular tool choice, you've actually locked yourself into a business decision, which is pretty crappy. So the other thing that relational databases get right is SQL, right? And I wrote standard query language, and I couldn't just leave it there because that's like the big joke, right, that SQL is a standard, right? It's the most incredibly non-standard standard that I've ever seen. It makes web browsers look like this unified single ecosystem. And trust me, I'm a web developer. I know all about crappy standards, and SQL's the worst. But you know what? A lot better than not having it at all. SQL is portable enough that I can move from one relational database to another. And within the same database, I don't need to change my query language to speak to different kinds of data. So if I am using Postgres and I decide that I want to use HStore, I don't need to discover a new language to talk to my key value store. I can use the language I already know. And if I'm an Oracle user and I want to switch to Postgres, yes, I need to learn some differences in syntax. Yes, I need to learn about new tools and technologies. Yes, administration is going to be different, but the bulk of my knowledge transfers. This is, I know that people love to slag on SQL, but frankly, it's one of the big wins of the relational database world. But I think the most important thing that relational databases get right is this really deep respect for data. And I use this term to encompass a bunch of buzzwords like ACID and you know, I don't know, transactional support and all this crazy stuff. I'm just sort of using it as an encompassing thing as like, your database is the safe, central place for you to store your data. It really respects the fact that your data is incredibly valuable to you, that your data, you know, is your business, right? You know, when you look at a company like Facebook paying $1 billion for Instagram, what they're acquiring is a Postgres database of usernames, right? The value in that business and in a ton of businesses, it comes down to data, right? And relational database people get this. They understand that data is incredibly important and incredibly valuable. And as a web developer, this matches the way that I think about my problems as a developing website. I tend to believe that if I get the data model right, the rest of the website kind of falls out of that. The only time I really do any sort of big design up front as a web developer is when I sit down to sort of model out and design how I'm going to store my database. And again, relational databases are really fantastic about this. They're very flexible. They can kind of model just about anything. And they give me a lot of options to store my data in. I kind of have this, I have some guidelines in these sort of normal form ideals, but relational databases don't, you know, enforce normal forms. It's just sort of a best practice, something that you learn as theory. In fact, you know, the database is kind of mine. I can choose how I want to store and model my data to both good and bad effect. Okay, so we might as well talk about NoSQL as well. And I'm, you know, risking getting dead fruit thrown at me. So look, there's a ton of hype here, and I'm suspicious of hype like everyone else. And I do think that there's a lot of BS on both sides talking about NoSQL. But there is some important stuff here. And I want to dive in and talk about what I think that NoSQL databases are doing right, again, from a web developer's perspective. So NoSQL databases generally are incredibly easy to get started with. You know, Redis is a cool example in that you download it, you type make, and then you run it. There's actually no configure step. I decided not to use autoconf, thank you. There's no install step. There's no configuration file. There's no access control file. Once you have the binary, you just run it. And these days you can download a binary for most packages, so that step turns into download, decompress, run. Incredibly easy to get started. And once the thing's running, you just kind of throw data at it. There's no create table. There's no modeling step. There's no, you know, there's no bureaucracy between just shoving data at the database. I can go from, you know, no CouchDB install on my laptop to hurling data at it within about 5 minutes, right? This is important for, this is why the adoption curve for these technologies has been this like crazy hockey stick, because it doesn't take very long to get something awesome happening. Kathy Sierra has written a bunch about sort of the experience that new users have when they encounter new software. And she says that as an author of a piece of software, you should try to make sure that your users experience their first moment of epic win within about half an hour, right? And we all know this feeling as software developers. It's the like, you know, hell yeah, I did that, right? We know how awesome that is. And when you have that feedback, that instant feedback that, hey, this thing actually works within a really short period of time, you tend to gain converts really quickly. But this isn't important for hobbyists, just for hobbyists. It's also really important to enterprise adoption. I've spent most of this summer teaching Django to a bunch of engineers at a Fortune 500 publicly traded company. The reason that they chose Django, ultimately, I mean, there were a bunch of meetings and there were a bunch of debates, and like all enterprise companies, they started this decision probably 3 years ago. But ultimately, the reason that they used Django is because the CTO downloaded it one afternoon, went through the tutorial, and had a working replacement for a crappy internet app that afternoon, right? And ultimately, no one could defeat the argument that that this guy made, which is, look, I haven't written software in a decade, and I managed to replace this app that we spent $1 million on in an afternoon, right? That's what enterprise adoption really looks like. It looks exactly the same as hobbyist adoption. And if your tool has incredibly easy onboarding, someone's going to become an evangelist for you inside other communities and inside organizations. Okay, so schemaless, right? I don't think that schemaless data storage is actually important for the reasons that most people think it is. The argument that a lot of NoSQL proponents like to make is that schemaless data store means you don't have to spend time thinking about and worrying about your data model. I actually think that's totally bunk. In fact, schemaless requires you to spend more time. It's more difficult to think about how to model your data because you don't have these long-established best practices like normal form to fall back on, right? You can't just say, well, I'll go third normal form for now, and then we'll see if I need to denormalize later on. You don't have that sort of easy choice. You have to really think about how you want to store and model your data. No, where I think schemaless is important is in its sort of intense pragmatism, right? I mentioned that one of the great things about relational databases is that they respect you enough to let you decide how to model your data. Well, schemaless goes even further, right? It says, I don't really care how you store this data, right? You give me data and I will store it. And that pragmatism lets you, it helps with onboarding, but it also really helps with designing things that just don't fit within normal forms. Joe Stump likes to say that over time your data models evolve over time your database models evolve until they match your UI. Because the dirty secret of web development is that your nice, clean relational database really doesn't survive its first contact with actual traffic. And this is where schemaless really shines, right? So Ned Batchelder, a Python developer and good friend of mine, says that in relation to static versus dynamic language, that static languages prevent certain types of failures, but they also prevent certain types of successes. So I've ripped off his quote, and schemas prevent certain types of failures, but they also prevent certain types of successes, right? I always find it kind of weird that you've got Python, which is this very sort of dynamic and open language, and then you back it up with traditionally a relational database that says, no, you must conform to schema. So I think that this better match between the sort of dynamic mode of thinking is one of the reasons why schemaless is an important feature of non-relational databases. And so finally, the last one is these NoSQL databases tend to be a lot easier to scale out, or at least to shard, at least in sort of some of the trivial definitions of this term. This is a huge area, and I'm wary of saying that NoSQL scales better because that's such a huge claim. But in a lot of trivial cases, it's much easier to sort of set up a cluster than it is with a traditional relational database. You know, like Redis is the king here, right? You pop open a new Redis instance, you type slave of IP address, and now you've got a read slave, right? No configuration files, no shipping data, you just say, hey, you're a slave of this one, right? And it just sort of works the way you expect. And most non-relational databases tend to focus on this sort of trivial read slaves or easy sharding, or those sorts of sort of quick wins, right? They're not a solution for every use case, and they're not a solution for the most complicated use cases, but they're a win for the sort of easy, you know, crap, I/O performance on AWS is terrible, I need more nodes. Just for one example, you know. So if you put this all together, right, we can see that these databases have like non-overlapping wins, right? They're not relational versus non-relational. It's not a symmetrical battle. They're not competing on the same sets of features. They're competing on non-overlapping and sort of orthogonal features to each other. I see no reason why we can't have all of these features in a single database. There's nothing, at least to me, that says that these things stand in conflict to each other. So that's what I mean when I say a post-SQL database. It's one that learns the lessons of everything that came before it, doesn't throw them out. This isn't NoSQL, right? We haven't said, to hell with that. We've said there's some really good ideas here, and there's some really good ideas here, and let's bring them all together into one place and make a sort of single-stop shop for all of your data storage needs. So I did a little imagining, you know, what this would look like, how this would actually work. Just sort of a basic idea here of what I'm envisioning. But so installation, you just download it and run it. Runs non-privileged, no configuration files, no setup, no nothing. You just run it. It runs. By default, it should be fast enough. By default, it should be secure. If you want to configure any of that, sure, fine, have configuration files, but they're not required. You just download it and run it. If it doesn't use autoconf, even better. And as soon as it's running, type some insert statements, right? So I think some people, like old school DBAs, probably freaked out here, right? Just had a little heart attack, because there's SQL, but there's no like create table statement. I haven't even told the database, you know, what this table is. But I mean, why can't the database just say, okay, you've referenced a table that doesn't exist, I'll make it, right? Same thing we do in dynamic languages. You know, the question, oh, what if I misspell cities? Yeah, don't do that. You get another table. It's the same, but it's the same in dynamic languages, right? What if I add a new field? Great, store a new field. But what's kind of neat about this is, right, it's just SQL, right? Right? And what you're not seeing, what I can't show you in a little like stupid made up example, is that, you know, presumably behind the scenes we're actually running inside a transaction, we're ACID compliant, and et cetera, right? All that sort of boring under the hood stuff that I love that I don't need to know anything about because the database just sort of magically does it for me, right? I don't want to think about what my data loss scenarios are. I just want them to not exist. And I ought to be able to pop open a second node and type slave of other node, and now I've got a read slave. And you know, I think you can go a lot farther than read slaves. I mean, there's a ton of prior art in how to do clustering of databases. And I'm completely an amateur here, but it seems to me that the Postgres community is kind of full of some of the smartest people in these worlds who surely understand this stuff a lot more than I do. And it seems like this sort of magic database ought to be able to do maybe auto sharding. Maybe they've got some sort of built-in key servers so that you can have multi-master with non-overlapping keys. Maybe something like cool and magical like vector clocks. I don't know. I'm waving my hands here. I'm making shit up. But look, the fact is this stuff is not, these problems are not new, right? The issues of keeping data distributed over multiple systems, even geographically distributed, are not, these problems we've been fighting these problems for a lot of years. We have a ton of knowledge there. It's completely reasonable to expect that some new tool will figure out how to solve them in a way that looks like this to the user, but actually, actually does it in a very, in a more generally applicable way than just a sort of boring read slave. Okay, so what's it going to take to get Postgres to become PostSQL? I think there's a ton of opportunity. I think of all the databases on the market, free and non-free, Postgres is the one that's best positioned to become this database that I'm dreaming of. I think all the other ones have a much harder hill to climb, and I think to some extent, deliberately or not, Postgres has started to walk down this path. So Postgres is still not as easy to install and configure as it ought to be. It's much easier than it used to be. Like I said, steps are being taken here, but there's still some tricky configuration, and the out-of-the-box tuning is not optimal for sort of the average, at least the average web developer use case. Again, that's my perspective here. Postgres already has a bunch of sort of schema-less or schema-less-ish features in the form of HStore and JSON fields and arrays and composites and all of these incredibly cool things. And those are fantastic, and I just love the way that Postgres kind of seamlessly blends these traditional relational types with these, like, yeah, you want an array? Sure, here's an array. It's this Postgres has long seemed to me to be rather unopinionated about, I don't feel like I'm being penalized when I go outside of standard relational normalization. And I think that Postgres could push this envelope a little further and really enter a world where sort of there's some kind of more hardcore schema-less support. And I think replication and scaling could be a lot easier. Again, major strides have been taken. It seems like each release of Postgres, setting up a replicant gets like, half again as hard, right? It's like it's kind of this asymptotic. It's getting closer and closer and closer and closer to being totally trivial. So I think, again, the direction is happening here. So the interesting thing about all of these, I think, thinking about them, is that most of them seem to be more cultural than technical, right? Most of what I'm describing is stuff that Postgres already can do, but it maybe isn't sort of advertised as the main feature. It isn't put in front. It's not front and center in the documentation, and it's not sort of prioritized by the community. This idea of auto-creating tables, right? Technically does not seem like that big a deal, right? But culturally, that's a pretty big shift, right? Selling that to people steeped in the traditional relational database world seems like a really hard sell. Seems like something that would be very, very hard to do. And it represents a shift in direction a lot bigger than the shift in technology. So I actually think the biggest changes here are really in sort of the way that the community thinks of itself and the way that the community positions itself. So I guess my main pitch to you, my main point that I want to make here is that if you make this shift, if you start thinking of yourselves as the first post-SQL database, you will create a tool that millions of people will thank you for every day. And thank you. So I can take questions? Yeah, I guess there's a microphone up here. Or I can just repeat them if it's... Just shout and I'll repeat it.
Two things. One is a quick comment. Richard, the creator of SQLite, actually came up with a similar term, actually, which was postmodern database.
All right. It's kind of a mouthful, but it's a good one. I like it.
Yeah. Have you seen his syntax for uncle?
No, I
which is an attempt to create a query language for unstructured, for schemaless databases.
Okay.
You might want to take a look because it's actually got some of the same ideas.
It's called Uncle?
Yeah. And I've been thinking about it in context of, if we had a fully indexed JSON type, how would we query it?
Mm-hmm. Yeah, I mean, it's an interesting question, and there's been a bunch of work in the sort of NoSQL crowd trying to come up with a unified query language. I was a sort of fly on the wall at some discussions, I think at OSCON, about a bunch of different ideas. But one of the issues is that the data storage types are so disparate that the more and more they talk, the more and more the language starts to sound like SQL to me. So I guess my opinion is that the language we've got is better than this made-up one that we don't have.
That's a good point. So thank you for that.
Thank you.
And I was curious, I very much agree with what you said about it being a pretty major cultural shift to focus more on the issues, the list of 3 things that you suggested that we do. So I'm wondering if there's a similar cultural shift that you can think of in another open source project where they were successful in driving that kind of a change.
I mean, I can't think of any ones. I can't think of any ones that major, but I can think of a lot that are sort of happening in that direction. In the web framework world, there's this sort of move to real time as sort of best demonstrated by Meteor, I guess, and watching other frameworks, including Django, trying to negotiate some of those cultural shifts is really interesting. We have a lot of commitment among the Django core team that we'd like to move Django to some degree in that direction. One interesting thing, though, is that's more or less going to require us to actually make a decision about front-end languages. We're going to have to choose jQuery or Backbone or something like that, which is not a technically hard decision, but something that we've historically avoided doing. And what's interesting is there seems to be a lot of, our community seems happy to let us make that call and back us up with it. I think most of the time these cultural shifts, I think they can't happen from the top. They have to be sort of driven kind of from underneath. And whether or not there's a critical mass of users within the Postgres community who want to see these sorts of things, that's something I don't know. I am too invested in the web world. I know there is in the web world, but I also know that Postgres has a much bigger sphere of influence. So, yeah, come up to the microphone if you want to ask a question.
Hello. Since you're in the user interface world, do you think there's something in SQL psychologically that prevents people from designing good user interfaces?
Well, I mean, I should say I'm not in the user interface world. I'm a middle tier developer.
Web world. I kind of consider the user interface now to be the web, and
well,
sort of.
You clearly haven't seen any of the websites that I make when I'm on my own. You're seeing the. No, I mean, this is actually a.
Because I guess my question really is it seems that Postgres needs better user interface tools.
You're talking about like graphical query tools and those sorts of things.
Things like that. I like the core being pristine. I like a simple, clean core because it makes it more predictable.
Right.
It just seems like there needs to be things filled out at userland level. I guess you can call it for the kernel. What are your ideas about that?
Well, I mean, I think that user interface design is a skill like any other, and we've all spent years sort of honing our particular skills, and I think the reason that most graphical query tools, look like they were designed by a DBA is because they were designed by a DBA, and that DBA probably is incredibly experienced in the database world, but really has no foundation in UI and UX. And I don't have any easy answers here. I mean, this has been a multi-year struggle for us within the Django project to get more more designers, more user interface engineers, more IA people involved and interested in the project. Brian Veloso, a designer at GitHub, gave a talk at DjangoCon a couple weeks ago on sort of attracting designerly people to your project. I don't believe that the video is online yet, but it'll be up on pyvideo.org eventually, and you can sort of find that talk and take a look at what he had to say. It's a similar problem that faced within our community as well.
Regarding security and ease of configuration, especially over a network, how do you see those two things working together? I mean, traditionally in Postgres, the thing that people might get stuck on where they need to configure it would be if they're connecting over a network and need to set up security.
Right. I mean, security is where like security and ease of use are always like right at at loggerheads with each other, and that's always the really hard thing to set up. I think if you look at the way that most, that Redis example I gave you was not, I was lying slightly, because in order to make that work, those two servers obviously have to be able to talk to each other, right? So I had to change the defaults on my master to have it be listening on a public address, and presumably I have to set up some sort of security over that channel. And Redis has some simple security, not anywhere close to where Postgres goes. So I think what you do is the defaults are single node, right? And once people are sophisticated enough that they want to set up multi-node stuff, at that point they'll be willing to edit configuration files. I think the important part for onboarding is just make sure that the defaults work right out of the box and let people go to the manual when they want to do something a little more complex.
Just wanted to say thank you very much for a great talk. The point I'd like to say is we are listening, and if you or other people have got new and inventive ideas, there's a code sprint on Thursday where we would very much like to talk about this kind of ideas, and everybody's welcome. We really do want to go for some of the innovative ideas you've discussed. Thank you.
Awesome, thank you. That's so great to hear. This is what's so great about speaking at open source conferences. Everyone's like, yes, I'll be working on that Thursday.
I feel database could play a major role in terms of productivity. In the web development perspective, what is your opinion if Postgres really helps productivity, or at least doesn't create problems in terms of productivity? Or
what's the other database? Sorry.
No, I'm talking about Postgres. In your opinion, compared to other main, other databases which are proprietary or, not as much of open source.
I mean, I honestly can't speak that much to Postgres compared to other things, because pretty much as long as I've been a web developer, Postgres has been my tool of choice. I've never had much of a reason until the last few years when I need these other things like queues and high-speed key value stores and those sorts of things. I haven't had much of a reason to look outside. So it's hard for me to draw much of a comparison other than, that stuff hasn't worked very well and Postgres has, so I'm still using it.
Did you encounter any problem? Have you ever felt that your productivity is kind of compromised due to limitations of database?
Not particularly. It's been a pretty happy choice for me.
So a number of years ago, Postgres took out all the code for type coercion that's done automatically, and things got a lot more difficult for a lot of applications, but whole classes of really evil eat my data bugs went away. How do changes like that fit into the postmodern database world that you're imagining?
Well, I mean, I'm a Python developer, right? So the Python answer is that Python is dynamically typed, but it's also strongly typed, which means variables can hold data of any type, but type coercion doesn't happen automatically. So I think that's clearly the right move, right? The idea that you add 1 and 1, and if one of them happens to be a string, you get 11, just makes me want to, vomit somewhere. But it is a line to walk, right? Because it's always, when you're walking up to this sort of schema-less line, you're trying to give people enough rope to hang themselves to some extent, right? You're trying to leave things open to the point that they can kind of do whatever they want. So, I would tend on the side of saying that type safety is probably a good thing, and that it sort of, to me, it falls under the rubric of, respect for data, right? Integers in, integers out, right? Don't do something weird to me inside. I think there's room for debate there. I think that it's an interesting question.
So we've reached the end of this session. Thank you very much, Jacob. And yeah.
Thank you all.